Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units, side CD equals to 2 units, and we also know that AD equals to CB, angle BAD equals to 30 degrees, angle ABC equals to 90 degrees, and we want to find out the area of this quadrilateral ABCD. So we'll start with the first method. In the first method we will do a construction. From point D we will draw perpendicular to AB. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We will define the touching point between the perpendicular from point D to AB as point E, and we will focus on the right triangle, triangle ADE. But before that we will define line segment ED as A, that is to say line segment ED equals to A units in its length, and we will focus on the right triangle, triangle ADE. In the right triangle, triangle ADE, sinus 30 degrees equals to DE over AD. I repeat again. In the right triangle, triangle ADE, sinus 30 degrees equals to DE over AD. We know that sinus 30 degrees equals to 1 over 2, so I write it down. We will get that 1 over 2 equals to DE over AD. One over 2 equals to DE over AD, but DE equals to A according to our definition. So we'll substitute DE by A, and we will get that 1 over 2 equals to A over AD. Here we will cross multiply equation number 1, and we will get that AD equals to 2A. So we actually found out that AD equals to 2A, so we can write here that AD equals to 2A. But it is given us in the question that AD equals to CB. According to what is given us in the question, AD equals to CB, and we found out that AD equals to 2A. So from this equation we will derive that CB also equals to 2A, CB equals to 2A, So we can write here that the length of side CB is actually equals to 2A units. CB equals to 2A. In the next step, we will draw perpendicular from point D to CB. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We will define the touching point between the perpendicular from point D to CB as point F. So here you can see that quadrilateral DFEB has three right angles, 1, 2, 3. We define angle EDF, this angle as angle X. In the next step I will present to you a new rule. Rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So I will read rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. And we found out that in quadrilateral DFEB, we have three right angles. The sum of three right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is defined as angle X. The sum of those four angles must be equal to 360 degrees according to this rule, rule number 1. Here we will subtract 270 degrees from this equation and we will get that angle X equals to 360 degrees minus 270 degrees, that is to say angle X equals to 90 degrees. So we found out that angle X is a right angle equals to 90 degrees. So we will substitute angle X by a right angle. So actually quadrilateral DFEB has four right angles, and we have also rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. I'm read rule number 2 again. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. Therefore, according to rule number 2, our quadrilateral DFEB is a rectangle according to rule number 2. Okay, so we will relate to quadrilateral DFEB, this quadrilateral is a rectangle, and we also have rule number 3. According to rule number 3, according to rule number 3, so according to rule number 3, the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other, and especially in rectangle DFEB, the opposite sides of rectangle DFEB are equal to each other. That is to say, ED equals to BF, ED equals to BF according to rule number 3. but ED equals to A according to our definition. So from this equation, we will derive that BF also equals to A. BF equals to A. So we can write here that BF equals to A. What is the value of CF from the drawing? You can easily see that CF equals to BC minus FB. Okay? From the drawing, you can easily see that CF equals to BC minus BF. So CF equals to BC, that is 2A, minus FB, that is A. 2A minus A is A. So we found out that CF equals to A. CF equals to A. Here CF equals to A. In the next step, we will join points B and D by a straight line. We join points D and B by a straight line, so here and we will prove that triangle DBF can go into triangle TCF. Triangle DBF congruent to triangle TCF. So why those two triangles can go into each other? First of all, BF equals to FC equals to A. I will repeat again. BF equals to FC equals to A. We also know that those two angles, they are equal to each other, they are both equal to 90 degrees. So angle BFD equals to angle CFD, this angle, and they are both equal to 90 degrees. I'll repeat again. Angle BFD equals to angle CFD equals to 90 degrees. And DF is a common factor, that is to say, it belongs to both triangles, so we can write down that DF equals to DF. It's a common side that belongs to both triangles. I will repeat again, DF equals to DF. It's a common side that belongs to both triangles. So we actually proved that triangle DBF, this triangle, DBF, congruent, this is the sign of congruent, to triangle DCF, according to side angle side rule. I'll repeat again. We proved that triangle DBF can go into triangle DCF according to side angle side rule. So, what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle that is located between those two sides in one triangle can go into two sides and the angle between those two sides in another triangle, then you proved that those two triangles can go into each other according to side angle side rule. And here you can see that we proved that those two sides and the angle between them, that is to say this angle, that is a right angle, can go into those two sides and the angle between them, that is to say this right angle, in another triangle. Therefore we proved that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that CD equals to DB. CD equals to DB. And actually, CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But it is given us in the question that CD equals to 2 units. From the question itself we know that CD equals to 2 units. From this equation we will derive that DB also equals to 2 units. Okay, DB also equals to 2 units. So we can write here that DB equals to 2 units. In the next step, I will present to you a new law that is actually the law of cosines. The law of cosines. The law of cosines is true in any triangle, so we can find out in any triangle so if we have triangle ABC that could be any triangle, this is triangle ABC. We know that the length of side AB is equal to A units, the length of side BC is B units, and the length of side AC is C units, and we also know that the angle between side AB and side BC is theta. Then, according to the law of cosines, A squared plus B squared minus 2 times A times B times cosine theta equals to C squared. Make A squared plus B squared minus 2 times A times B times cosine theta equals to C squared. Here we will subtract from this equation c squared, and we will also add to this equation 2 times AB cosine theta, and we will get that A squared plus B squared minus C squared equals to 2 times AB cosine theta. Here we will divide this equation by 2 times AB, and we will get that cosine theta equals to A squared plus B squared minus 2 times AB, A squared plus B squared minus 2 times A squared plus B squared minus C squared over 2 times AB. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. And this equation is true for any triangle. We can actually implement the law of cosine, cosines in our triangle ADB. So we will actually copy triangle ADB in a new page, and we will implement the law of cosines in this triangle. In triangle ABD, we know that AB equals to 4 units, AD equals to 2A units, angle DAB equals to 30 degrees, and DB equals to 2 units. So this is triangle ADB, and according to the law of cosines, we will get that cosine 30 degrees equals to 2A squared plus 4 squared minus 2 times minus 2 squared over 2 times 2A times 4. We know that cosine 30 degrees is actually square root of 3 over 2, and it equals to 2A squared is 4A squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, over 2 times 4 is 8, and 8 times 2A is 16A. So we will multiply this equation by 16A, and we will get that square root of 3 over 2 times 16A equals to 4A squared plus 12. And there 16 over 2 is 8. So we will get that 8 times square root of 3 times A equals to 4A squared plus 12. Here we will divide this equation by 4 and we will get that 8 over 4 is 2, so here we will have 2 times square root of 3 times a equals to 4 over 4 is 1, so we get here a squared. 12 over 4 is 3 plus 3. Here we will subtract from this equation 2 times square root of 3 times a, and we will get that a squared plus 3 minus 2 times square root of 3 times a equals to 0. We know that 3 equals to square root of 3 squared, so we will substitute 3 by square root of 3 squared here, and we will get that a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. So here this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times a times b equals to a minus b squared, that equals to 0. So according to this algebraic identity, we will get that our expression can be expressed by a minus b squared. In our specific expression, a equals to a and b equals to square root of 3 units. Therefore, a minus b, it will be actually a minus square root of 3 and square equals to 0. Okay, so here we will take a root out of this equation and we will get that a minus square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We will add to this equation square root of 3 and we will get that a equals to square root of 3 units. So we can write here that a equals to square root of 3 units, and also here a equals to square root of 3 units, and here also that a equals to square root of 3 units. Okay. So here we will focus on triangle EDF, and we will implement the Pythagoras theorem on the right triangle, triangle EDF. So in the right triangle, triangle EDF, so according to the Pythagoras theorem, if you focus on triangle EDF, the right triangle EDF, PT is the Pythagoras theorem, abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse, it is actually triangle EDB. We will focus on triangle EDB, this triangle, in the right triangle EDB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, DE square plus EB square equals to DB square. I repeat again, according to equation number 1 and Pythagoras theorem, DE square plus EB square equals to DB square. So DE equals to square root of 3. Therefore, DE square is square root of 3 square. Square root of 3 square is 3. Plus EB. EB is the missing variable, so we will leave it as it is. EB square equals to DB square. DB equals to 2, so DB square is 2 square. 2 square is 4. So we got that 3 plus EB square equals to 4. Here we will subtract from equation number 1 3, and we will get that EB square equals to 4 minus 3, that is 1. EB square equals to 1. So we will take a root out of this equation, and we'll get that EB equals to the square root of 1, and the square root of 1 is 1. So we found out that EB equals to 1 unit. EB equals to 1 unit, so we can write here that EB equals to 1 unit. But because of the fact that the opposite sides of a rectangle are equal to each other, so in rectangle EDFB, EB equals to DF. But EB equals to 1 unit, therefore DF will be also equal to 1 unit. What is the value of line segment AE? From the drawing, you can easily see that AE equals to AB minus EB. AE equals to AB minus EB. So AE equals to AB. AB is 4 units, EB is 1 unit, so 4 minus 1 is 3. So we found out that AE equals to 3 units. AE equals to 3 units. We can write here that AE equals to 3 units. Now we can easily find out the area of quadrilateral ABCD. The area of quadrilateral ABCD will be equal to the area of the right triangle AED, this right triangle, plus the area of rectangle EBDF, plus the area of the right triangle, triangle CDF, this right triangle. I repeat again, the area of quadrilateral ABCD will be equal to the area of the right triangle AED plus the area of rectangle EBDF plus the area of the right triangle CDF. And the area of triangle ADF, it equals actually to the base of the triangle, that is AE, times the height to the base, that is DE, over 2. So we found out that the area of the right triangle, triangle AED, equals to AE times ED over 2. The area of rectangle EBDF equals to the width of triangle EBDF times the length of triangle EBDF. The width of triangle EBDF is EB times the length of triangle EBDF, and the length of triangle EBDF is BF. So the area of rectangle EBDF equals to EB times BF, and the area of the right triangle, triangle CDF, equals to the base of the triangle, that is actually DF, times the height to the base, that is actually CF, over 2. So I repeat again, the area of the right triangle, triangle CDF, equals to the base of the triangle, that is the area of triangle CDF, the right triangle, triangle CDF, equals to the base of the triangle, that is DF, times the height to the base, that is CF, over 2. Okay, so here AE equals to 3 units times DE, DE equals to square root of 3 units over 2. So we found out that the area of the right triangle, triangle AED, equals to 3 times square root of 3 over 2, and the area of rectangle EBDF equals to EB, that is 1, but first of all we will write the letters. EB, but EB, we already write down EB times BF, so EB equals to 1, EB equals to 1 unit, and BF equals to square root of 3 units. So we found out that the area of rectangle EBDF equals to square root of 3 units, and the area of the right triangle, triangle CDF, equals to DF, DF is 1, times CF, CF is square root of 3, over 2. Okay, so the area of the right triangle, triangle CDF, equals to 1 times square root of 3 over 2. So here we will multiply square root of 3 by 2, and then we will divide it by 2 in order to have a common factor of the other two expressions. So we get here 2 over 2. In the next step, we will take a common factor of square root of 3 from those two expressions. So square root of 3 is a common factor. What we will get inside the brackets from this expression after we took from it square root of 3 is a common factor. What is left, it is actually 3. And what is left from this expression after we took square root of 3 as a common factor? What is left? It is actually 2. And what is left from this expression after we took square root of 3 as a common factor? What is left? It is actually 1. And in the denominator we have 2 for all 3 expressions. So we got that square root of 3 times 1 plus 2 is 3, 3 plus 3 is 6. So it is times 6 over 2. Here 6 over 2 is 3, 3 times square root of 3 is the area of quadrilateral ABCD. It equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, so we finished with the first method. In the next step I will present to you how to find out the area of this quadrilateral ABCD according to the second method. In the second method we will do another construction. From point C we will draw perpendicular to CB. So actually this angle will be a right angle, that is to say it will be equal to 90 degrees. And from point A we will draw perpendicular to AB. That is to say, this angle will be a right angle. That is to say, it equals to 90 degrees. And we will define the intersection point between the perpendicular from point A and the perpendicular from point C as point E. So, by doing our constructions, we actually created quadrilateral ABCE, this quadrilateral. In quadrilateral ABCE, we have 3 right angles, 1, 2, 3. And the sum of those 3 right angles, it is actually 90 degrees times 3 is 270 degrees, plus the side of this angle that we will define as angle X. So actually the sum of the 4 angles, that is actually 270 degrees plus X, must be equal to 360 degrees, according to rule number 1, that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees, that is to say angle X equals to 90 degrees. That is to say angle X is a right angle. So we can substitute angle X by right angle. So you can see from the drawing that all the angles of equilateral ABCE are right angles, and according to rule number 2, any equilateral that has 4 right angles must be at least a rectangle. So we will relate to equilateral ABCE as a rectangle. I'll repeat again. Equilateral ABCE is a rectangle according to rule number 2 because of the fact that it has 4 right angles. And according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle ABCE are equal to each other. That means that AB equals to EC, AB equals to EC according to rule number 3. I'll repeat again. AB equals to EC according to rule number 3. But it is given us in the question that AB equals to 4 units. AB equals to 4 units. From this equation, we will derive that EC also equals to 4 units. So here EC equals to 4 units. Likewise, AE equals to CB. AE equals to CB according to rule number 3. And so AE equals to CB according to rule number 3. And if we define AE as X, if AE equals to X, from this equation we will derive that CB also equals to X, CB equals to X, CB equals to X. In the next step, we will join points E and D together by a straight line. And we will also join together points D and B by a straight line. And here we know that angle BAE equals to 90 degrees and angle BAD equals to 30 degrees according to what is given us the question. Therefore, the value of angle EAD will be equal to 90 degrees minus 30 degrees, that is to say it equals to 60 degrees. And it is given us in the question that AD equals to CB. According to what is given us in the question, AD equals to CB. But we defined CB as X. From this equation we will derive that AD also equals to x. AD equals to x. So here we have triangle AED. I will draw triangle AED in a new page and we will analyze triangle AED that has two equal sides. And we also know that angle DAE equals to 60 degrees of triangle AED. So I will draw triangle AED in a new page. So this is actually triangle AED. In triangle AED we have two equal sides, that is to say AE equals to ED equals to x, and we know that in front of equal sides in the triangle there are equal angles. That is to say, those two angles that are located in front, the equal sides must be also equal to each other. So those two angles must be also equal to each other. And if we define this angle as phi, then this angle must be also equal to each other because of the fact that those two angles are equal to each other. And we also know that the sum of the angles in any triangle is equal to 180 degrees. And especially in triangle AED, the sum of its angles must be equal to 180 degrees. That is to say, angle y plus angle y plus 60 degrees must be equal to 180 degrees. Here we will subtract 60 degrees from this equation and we get that y plus 2y, y plus y is 2y, and it equals to 180 degrees minus 60 degrees. It equals to 120 degrees. So here we will divide this equation by 2, and we will get that angle y equals to 180 degrees over 2 is 60 degrees. So we found out that angle y equals to 60 degrees. So we will substitute y by 60 degrees. And then also angle y equals to 60 degrees. So here we found out that triangle EAD is an equilateral triangle. Triangle ADE is an equilateral triangle. Triangle AD is an equilateral triangle. And any equilateral triangle, all of its angles are equal to each other, so ED must be also equal to x, and all of its angles, as you can see from the drawing, are equal to 60 degrees. So in the original drawing, we can write down that angle at that side D equals to x, this angle equals to 60 degrees, and this angle also equals to 60 degrees. What is the value of angle DEC? Angle AEC equals to 90 degrees, so 90 degrees minus angle AED, that is 60 degrees, must be equal to this angle. That is to say, angle CED equals to 90 degrees minus 60 degrees, it is actually 30 degrees. Okay? In the next step, we will prove that those two triangles can go into each other. So why those two triangles can go into each other? We will actually prove that triangle ADB, this triangle, and triangle CDE, this triangle, can go into each other. So why those two triangles can go into each other? First of all, we know that AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. I'll repeat again. AB equals to EC equals to 4 units. We also know that those two angles are equal to each other, they are both equal to 40 degrees. So angle BAD angle DAB, this angle, can go into angle, this angle DEC. Angle DEC. And both those two angles are equal to 40 degrees. So I'll repeat again. Angle BAD equals to angle DEC equals to 40 degrees. And AD equals to ED equals to X. I'll repeat again. AD equals to ED equals to X. So we actually proved that triangle ADB can go end to triangle EDC. EDC according to side angle side rule. So I'll repeat again. We actually proved that triangle ADB congruent to triangle EDC according to side angle side rule, and from the fact that those two triangles congruent to each other, we will conclude that CD equals to DB. CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But it is given us in the question that CD equals to 2 units. So from this equation, we'll derive that DB also equals to 2 units. Okay, so DB equals to 2 units. We can write here that DB equals to 2 units. In the next step, we will implement the law of cosines in triangle ADB. So I will copy triangle ADB in a new page, and we will implement the law of cosines on this triangle. Okay? So actually this is triangle ADB. AB equals to 4 units, DB equals to 2 units, and AD equals to X. And angle DAB equals to 30 degrees. According to the law of cosines, we will get that cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4 . We know that cosine 30 degrees equals to square root of 3 over 2, and it equals to x squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, so in the numerator we have x squared plus 12, and in the denominator we will have 2 times 4 is 8, 8 times x is 8x. Here we will multiply this equation by 8x, and we will get that square root of 3 over 2 times 8x equals to x squared plus 12. So here we will 8 over 2 is 4, so we will get that 2 times square root of 3x equals to x squared plus 12. Here we will subtract 4 times square root of 3x from this equation, and we will get that x squared plus 12 minus 4 times square root of 3x equals to 0. Here we will substitute 12 by 2 times square root of 3 square. 2 times square root of 3 square equals to 12, so you can substitute it by this expression. So we will get that x squared plus 2 times square root of 3 squared, that is 12, minus, we will substitute 4 by 2 times 2, and we will get that is 2 times x times 2 times square root of 3, that equals to 0. So we got this expression. Actually, this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. According to this algebraic identity, we can substitute our expression by a minus b squared, and in our specific expression a equals to x and b equals to 2 times square root of 3. So a minus b squared will be equal to x minus 2 times square root of 3 squared, that will be equal to 0. So here we will take a root out of this expression, and we will get that x minus 2 times square root of 3 equals to 0, because of the fact that the square root of 0 is 0. We will add 2 times square root of 3 to this equation, and we will get that x equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units. So now we can calculate the area of quadrilateral ABCD. The area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle BDC. Okay, so I will write it down. The area of quadrilateral ABCD equals to the area of triangle ADB, this triangle, plus the area of triangle BDC. I will repeat again. The area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. In order to find out the area of triangle ADB, we will draw a perpendicular from point D to AB. And we define the touching point between the perpendicular from point D to AB as point S. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We will define ds as h, abbreviation for height. In the right triangle ADB, we will get that sinus, so in the right triangle ADS, this is actually triangle ADS. We will get that sinus 30 degrees equals to h over x, that is 2 times square root of 3 units. Sinus 30 degrees equals to h over 2 times square root of 3 units. I will repeat again. In the right triangle ADS, sinus 30 degrees equals to h over 2 times square root of 3 units. Sinus 30 degrees is 1 over 2, so I write it down. We get that 1 over 2 equals to h over 2 times square root of 3. We will multiply this equation by 2 times square root of 3, and we will get that 2 times square root of 3 over 2 equals to h. 2 over 2 is 1. So we got that the value of h is square root of 3 units. So we can write down that h equals to square root of 3 units. Now we can easily find out the area of triangle ADB. The area of triangle ADB will be equal to the base of the triangle, that is actually AB, times the height to the base, that is actually h, over 2. I will repeat again. The area of triangle ADB equals to the base of the triangle, that is AB, times the height, that is h, over 2. AB equals to 4 units, h equals to square root of 3 units, all divided by 2. So the area of triangle ADB equals to 4 over 2 times square root of 3. 4 over 2 is 2. So we found out that the area of triangle ADB equals to 2 times square root of 3 square units. The only thing that is left to do is to find out the area of triangle DBC, this triangle. We will find out the area of triangle DBC according to a special formula. So the area of triangle DBC will be equal to, first of all, we will calculate the semi-perimeter of this triangle DBC. The semi-perimeter of any triangle is equal to the perimeter over 2. The perimeter of triangle DBS so this is 2 plus 2 plus 2 times square root of 3. I repeat again, the perimeter of triangle DBC is 2 plus 2 plus 2 times square root of 3. And if we divide the perimeter by 2, we will get the semi-perimeter. We divide it by 2 and we will get the semi-perimeter. S is the semi-perimeter. So S equals to 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2. 2 times square root of 3 over 2 is square root of 3. So in conclusion, we found out that the semi-perimeter of triangle DBC equals to 2 plus square root of 3 units, and the area of triangle DBC is equal to the square root of S times S minus A times S minus B times S minus C. We have already found out that S, the semi-perimeter of triangle DBC, equals to 2 plus square root of 3 units. And A equals to 2 units, B equals to 2 units, and C equals to 2 times square root of 3 units. So we will put the data inside this formula, and we will get that the area of triangle DBC equals to the square root of S is 2 plus square root of 3 units, S minus A, here 2 minus 2 is 0, so we left only with square root of 3. S minus B will be equal also to square root of 3 units, times S minus C. This is 2 plus square root of 3 units minus 2 times square root of 3 units. It is actually 2 minus square root of 3 units. So here, square root of 3 times square root of 3 is 3. And 2 plus square root of 3 times 2 times 2 minus square root of 3 is, we will find the value of this expression according to the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A equals to 2, so A squared is 2 squared, 2 squared is 4, minus B squared. B is square root of 3, so B squared is 3. So here 4 minus 3 is 1, 1 times 3 is 3, so we found out that the area of triangle DBC equals to square root of 3 square units, and the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DBC. We found out that the area of triangle ABD is 2 times square root of 3 units. And the area of triangle DBC is 1 times square root of 3 units. So 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 units. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, so we finished with the second method. In the next step, I will summarize the lecture. So we actually found out the area of quadrilateral ABCD in 2 different methods. In the first method, in the first method, we did a construction. From point D, we drew perpendicular to AB, so this angle is 90 degrees, this angle is 90 degrees. We defined the touching point between the perpendicular from point D to AB as point E. So triangle ADE is a right angle. We define DE as A, that is to say DE equals to A units in its length. Then we focus on triangle ADE, on the right triangle, triangle ADE. On the right triangle, triangle ADE, we know that sinus 30 degrees equals to DE over AD. And sinus 30 degrees is 1 over 2 equals to DE over AD. DE is defined as A, so we can substitute DE by A. We got that 1 over 2 equals to A over AD. We cross multiplied equation number 1 and we found out that AD equals to 2A. So here AD equals to 2A, but it is given us in the question that AD equals to BC. Here AD equals to BC, and we have already found out that AD equals to 2A. So from this equation we will conclude that here from this expression we will conclude that CB also equals to 2A. Here also CB equals to 2A. Then we drew perpendicular from point D to CB, so this angle equals to 90 degrees. And angle CBA equals to 90 degrees according to what is given as the question. And we drew two perpendiculars from point D. So quadrilateral DFEB is three right angles, and I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So quadrilateral DFEB is three right angles. The sum of three right angles is 270 degrees, plus the size of this angle that is defined as angle X must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation and we got that angle X equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle X equals to 90 degrees. That is to say all four angles inside quadrilateral AFEB are right angles. And we have rule number 2 that states any quadrilateral that has four right angles must be at least a rectangle if not a square. And because of the fact that quadrilateral DFEB has four right angles, we will relate to it as a rectangle. Okay? And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB must be equal to each other according to rule number 3. It means that DE equals to FB according to rule number 3. But DE equals to A according to our definition. From this equation we will conclude that BF also equals to A. BF equals to A. And what is the value of CF? CF equals to CB minus FB. Again, CF equals to CB minus FB. CF equals to CB or BC minus FB. So CF equals to BC, that is 2A minus FB, that is A. So CF equals to 2A minus A, that is to say CF equals to A. So we found out that CF equals to A. Then we join together points D and B by a straight line. And we actually proved that those two triangles can go into each other. That is to say, triangle DBF can go into triangle DCF. Why they can go into each other? First of all, BF equals to FC equals to A. Here, BF equals to FC equals to A. Angle BFD equals to angle CFD equals to 90 degrees. Those two angles are right angles, therefore they are equal to each other. And we also have a common side, DF equals to itself, DF equals to DF is a common side that belongs to both triangles. So we proved that triangle DBF can go into triangle DCF according to side angle side rule. Okay? And from the fact, you can see here, we have those two sides and the angle between them in triangle CDF can go into those two sides and the angle between them in triangle DBF, and therefore those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we will conclude that CD equals to DB, CD equals to DB, according to the rule that corresponding sides and congruent triangles are equal to each other. But it is given us in the question that CD equals to 2. So from this equation we will derive that BD also equals to 2 units. BD equals to 2 units. Then I presented to you the law of cosines. The law of cosines is true in any triangle. If we have triangle ABC that could be any triangle, the length of AB is A units, the length of AC is C units, and the length of AC is B units. Then according to the law of cosines, A squared plus B squared minus 2 times AB cosine theta equals to C squared. We subtracted C squared and added 2 times AB cosine theta to this equation, and we got that A squared plus B squared minus C squared equals to 2 times AB cosine theta. We divided this equation by 2 times AB, and we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. This equation is true in any triangle. We implemented the law of cosines in our triangle ADF, so I copied triangle ADF in a new page, and we implemented the law of cosines in this triangle. So this is triangle, this is actually triangle ADB. This triangle is triangle ADB. We know that AD equals to 2A, DB equals to 2 units, and AB equals to 4 units. Angle DAB equals to 30 degrees. According to the law of cosines, cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. Cosine 30 degrees is equal to 3 over 2. 2A squared is 4A squared. 4 squared is 16, minus 2 squared is minus 4. 16 minus 4 is 12. So in the numerator we have 4A squared plus 12. And in the denominator we have 2 times 4 is 8. 8 times 2A is 16A. In the denominator we have 16A. So here we multiply this equation by 16A. And we got that square root of 3 over 2 times 16A equals to 4A squared plus 12. Here it is plus 12. Okay. Here 16 over 2 is 8. So in this side of the equation we have 8 times square root of 3 times A equals to 4A squared plus 12. We divided this equation by 4 and we got that 8 over 4 is 2. So in this side of the equation we have 2 times square root of 3 times A that equals to, so 4 over 4 is 1. So here what is left is only A squared, as 12 over 4 is 3. So we got the 2 times square root of 3 times A equals to A squared plus 3. We subtracted 2 times square root of 3 A from this equation, and we got that A squared plus 3 minus 2 times square root of 3A equals to 0. Here we substituted 3 by square root of 3 squared. and we got that a squared plus square root of 3 squared, that is actually 3, minus 2 times a times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to a and b equals to square root of 3 units, so a minus b squared will be equal to a minus square root of 3 squared, that equals to 0. We took a root of this expression, and we got that a minus square root of 3 equals to 0, because the square root of 0 is 0. We added square root of 3 to this equation, and we got that a equals to square root of 3 units. So here we can write down that a equals to square root of 3 units, here also a equals to square root of 2 units, and here also a equals to square root of 3 units. Okay, and here also a equals to square root of 3 units. And then we implemented the Pythagoras theorem in the right triangle, triangle DEB. In the right triangle, triangle DEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say DE squared plus EB squared equals to DB squared. DE equals to square root of 3, so DE squared is the square root of 3 squared, the square root of 3 squared is 3. EB squared is EB squared, and DB equals to 2, so DB squared is 2 squared, 2 squared is 4. So we got that according to equation number 1, 3 plus EB squared equals to 4. We subtracted 3 from this equation, equation number 1, and we got that EB squared equals to 4 minus 3 is 1. We took a root out of this equation, and we got that EB equals to the square root of 1. The square root of 1 is 1, so EB equals to 1. Here EB equals to 1, but because of the fact that the opposite sides of a rectangle are equal to each other, so if EB equals to 1, then DF must be also equal to 1. What is the value of AE? From the drawing you can easily see that AE equals to AB minus EB. Again, AE equals to AB minus EB. AB is 4, EB is 1, so AE equals to 4 minus 1, that is to say AE equals to 3 units. Now we can easily find out the area of quadrilateral ABCD. Because the area of quadrilateral ABCD will be equal to the area of the right triangle ADE plus the area of quadrilateral DFEB plus the area of the right triangle DCF. I repeat again, the area of quadrilateral ABCD equals to the area of triangle AED plus the area of rectangle EBDF plus the area of the right triangle, triangle CDF. The area of triangle AED equals to AE, that is the base of the triangle, times the E, that is the height, over 2. AE equals to 3 units. DE equals to square root of 3, all divided by 2, so we found out that the area of triangle AED equals to 3 times square root of 3 over 2. The area of rectangle EBDF equals to EB times DF. EB is 1 and BF is square root of 3, so the area of rectangle EBDF equals to square root of 3 square units, and the area of the right triangle CDF is DF times CF over 2. DF is 1, CF is square root of 3, all divided by 2. And we multiplied this expression by 2, and then we divided it by 2 in order to have a common factor with the other two expressions. Then we took square root of 3 as a common factor from those three expressions. So square root of 3 is a common factor. So what is left from this expression after we took square root of 3 as a common factor? What is left? It is actually 3. What is left from this expression? What is left is 2. And what is left from this expression after we took square root of 3 as a common factor? What is left? It is actually 1. All divided by 2. So the area of quadrilateral ABCD equals to 3 plus 2 is 5, 5 plus 1 is 6, 6 over 2 is 3. So in conclusion, we found out that the area of quadrilateral ABCD, according to the first method, equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. We finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD according to the second method. In the second method, we did another construction. Actually, from point A, we do perpendicular to AB, so this angle is 90 degrees. And from point B, from point C, we do perpendicular to CB, so this angle also equals to 90 degrees. And we define the intersection point between the perpendicular from C and the perpendicular from A as E. And actually, we created here quadrilateral ABCE that has 3 right angles, 1, 2, 3. We define the fourth angle as angle X, and we know that the sum of the angles in any quadrilateral is 360 degrees, so in quadrilateral ABCE, the sum of 3 angles is 270 degrees, plus the size of the fourth angle, that is angle X, must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation, and we got that angle X equals to 90 degrees. So quadrilateral ABCE has 4 right angles. Therefore, according to rule number 2, quadrilateral ABCE is a rectangle. We have rule number 3 that the opposite sides of a rectangle are equal to each other. That is to say AB equals to CE. AB equals to CE, but it is given us in the equation that AB equals to 4. From this equation, we will derive that EC also equals to 4. Likewise, according to rule number 3, AE equals to BC. We defined AE as X, so BC will be also equal to X. So AE equals to BC equals to X. And here we know that it is given us in the question that AB equals to CD. Here AD equals to CB. But we defined CB as X. From this equation we will derive that AD also equals to X. So here AD equals to X. Okay. And here we drew perpendicular from point A, so this angle is a right angle, it equals to 90 degrees. And this angle is given us is 30 degrees. So the value of this angle is 90 degrees minus 30 degrees, that is to say this angle equals to 60 degrees. So in triangle AED, we have one angle that equals to 60 degrees, and we have 2 equal sides. Both those 2 sides are equal to X. So I drew triangle AED in a new page, and we analyze triangle AED. This is triangle AED. We know that those 2 sides are equal to each other. This angle equals to 60 degrees. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say those 2 angles must be equal to each other. If this angle is y, this angle also is y. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say y plus 60 degrees must be equal to 180 degrees. Y plus y is 2y. We subtracted 60 degrees from this equation, and we got that y plus y equals to 180 degrees minus 60 degrees is 120 degrees. So we got that 2y equals to 120 degrees. We divided this equation by 2, and we got that angle y equals to 180 degrees over 2 is 60 degrees. So this angle equals to 60 degrees and this angle also equals to 60 degrees. So we got triangle AD is an equilateral triangle, that is to say all of its sides are equal to each other, so ED will be also equal to x. And here we can write down that ED equals to x, this angle is 60 degrees and this angle is 60 degrees. But because of the fact that angle AEC is a right angle and this angle is 30 degrees, then this angle must be equal to, okay, so it is 60 degrees, but then we actually proved that those two triangles can go into each other. Okay, we know that this angle is 60 degrees and angle AEC is a right angle. So 90 degrees minus 60 degrees is the value of this angle. That is to say angle DEC equals to 30 degrees. So those two angles, they are both equal to 30 degrees. Because angle DAB equals to 30 degrees according to what is given us in the question. Then we prove that those two triangles can go into each other. That is to say, triangle ADB can go into triangle CDB. Why? Because AB equals to EC equals to 4, AB equals to CE equals to 4 units. Those two angles are equal to each other. Angle BAD equals to angle DEC equals to 30 degrees. And AD equals to DE equals to x. So we proved that triangle ADB can go into triangle EDC according to side angle side rule. From the fact that those two triangles can go into each other, we will conclude that CD equals to DB. CD equals to DB, but because of the fact that CD equals to 2 units, it is given as the question, we will derive from this equation that BD equals also to 2 units. BD equals to 2 units, then we implemented the law of cosines on triangle ADB. So I copied again triangle ADB in a new page, and we implemented the law of cosines on this triangle, triangle ADB. So this is triangle ADB in a new page. AD equals to x, DB equals to 2 units, AB equals to 4 units, angle DAB equals to 30 degrees. According to the law of cosines, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. X squared plus 4 squared is 16. Minus 2 squared is minus 4. 16 minus 4 is 12. So in the denominator we have x squared plus 12, and in the numerator we have x squared plus 12, and in the denominator we have 2 times 4 is 8, and 8 times x is 8x, so in the denominator we have 8x. We multiply this equation by 8x, and we got that 2 times square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4, so in this side of the equation we have 4 times square root of 3 times x equals to x squared plus 12. Here we subtracted 4 times square root of 3x from this equation, and we got that x squared plus 12 minus 4 times square root of 3x equals to 0. We know that 12 is equals to 2 times square root of 3 squared, so we substitute the 12 by 2 times square root of 3 squared, and we got this expression, x squared plus 2 times square root of 3 squared is 12, minus, we substituted 4 by 2 times 2, so here we have 2 times x times 2 times square root of 3, that equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3, so we can substitute our specific expression by a minus b that equals to 0. But in our specific expression, a is x and b is 2 times square root of 3. So a minus b squared will be equal to x minus 2 times square root of 3 squared, that equals to 0. We took a root out of this expression and we got that x minus 2 times square root of 3 equals to 0 because the square root of 0 is 0. We added 2 times square root of 3 to this equation and we got that x equals to 2 times square root of 3 units. So we found out that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. Here x equals to 2 times square root of 2 units, and here also x equals to 2 times square root of 3 units. Now we can easily find out the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DCB. Okay, the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. In order to find out the area of triangle ADB, we calculated the height of triangle ADB. From point D, we draw perpendicular to AB. We define the touching point between the perpendicular and AB is point S. So this angle equals to 90 degrees and this angle equals to 90 degrees. We define DS as H. In triangle ADS, we know that sinus 30 degrees equals to H over 2 times square root of 3 units. I'll repeat again. In triangle ADS, sinus 30 degrees equals to H over 2 times square root of 3 units. We know that sinus 30 degrees is 1 over 2, so we got that 1 over 2 equals to H over 2 times square root of 3. We multiplied this equation by 2 times square root of 3, and we got that H equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we found out that H equals to square root of 3 units. Now we can easily find out the area of triangle ADB, because the area of triangle ADB equals to the base of the triangle that is AB times the height that is H over 2. Again, the area of triangle ADB equals to the base of the triangle that is AB times the height that is H over 2. The base AB equals to 4, the height H equals to square root of 3 units, all divided by 2. 4 over 2 is 2. So we actually found out that the area of triangle ADB equals to 2 times square root of 3 square units. Then we found out the area of triangle DBC. According to a special formula, we actually calculated the semi-perimeter of triangle DBC. The semi-perimeter of any triangle equals to the perimeter over 2. The perimeter of triangle DBC equals to the sum of its sides, that is to say it equals to 2 plus 2 times square root of 3. And when we divide it by 2, we will get the semi-perimeter, so we divide it by 2. So the semi-perimeter is 4 plus 2 times square root of 3 over 2. 4 over 2 is 2. 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DBC is 2 plus square root of 3 units. And the area of triangle DBC, we calculated it according to a special formula. The area equals to the square root of S times S minus A times S minus B times S minus C, when S is the semi-perimeter of the triangle, that we found out that it's actually 2 plus square root of 3. A equals to 2, B equals to 2, and C equals to 2 times square root of 3. So the only thing that is left to do is to put the data inside this equation, and here S is 2 plus square root of 3, S minus A is 2 plus square root of 3 minus 2, that is to say square root of 3. S minus B is the same because A equals to B, so S minus B is square root of 3, and S minus C, it is actually 2 minus square root of 3. Square root of 3 times square root of 3 is 3. 2 plus square root of 3 times 2 minus square root of 3. We calculated this expression according to the algebraic identity that states that A minus B times A plus b equals to a square minus b square. Here a is 2, so a square is 4. B is equal to 3, so b square is 3. So 4 minus 3 is 1. 1 times 3 is 3. So we found out that the area of triangle DBC is equal to 3 square units. And the area of quadrilateral ABCD equals to the area of triangle ABD plus the area of triangle DBC. The area of triangle ABD is 2 times square root of 3 square units, and the area of triangle DBC equals to 1 times square root of 3 square units. 2 times square root of 3 units plus 1 times square root of 3 units equals to 3 times square root of 3 units. So we found out in both methods that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. Okay, thank you very much.